Hello friends, hello friends and my dear students. I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 21 video from the chapter of Physical Quantities and Measurements on the topic of sinking and floating, where I will solve 5 multiple choice questions based on the video part 19 and 20. This is about how to find the relative density of a solid which is denser than water at 4 degrees centigrade from its apparent weight or loss in weight in water at 4 degrees centigrade, and also how to find the relative density of a liquid based on the loss in weight of a body in the liquid and water in at 4 degrees centigrade. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 21 video, where I will solve 5 multiple choice questions based on video 19 and 20. Okay, so the first question says that a solid body having a relative density x which is greater than 1 has an apparent weight of y gram force in water at 4 degree centigrade. Then the weight of the body in gram force in air is. Now I will not explain the concepts and formulas related to finding the relative density of a solid based on its loss in weight or apparent weight in water at 4 degrees centigrade. For that, please watch video part 19 and 20. Okay, so we know that when a solid body is which is denser than liquid, denser than water at 4 degrees centigrade, which basically means whose density is greater than 1 or relative density is greater than 1, it gets completely immersed. And we know that the loss in weight is the buoyant force that the body experiences by the water, and we also know that the relative density in that case for the body. So a body, so we know that the scenario is something like that. This is the the body, since it is denser than water at 4 degrees centigrade, it will be completely immersed, and the buoyant force or the upthrust is Fb. This is basically the loss in weight. Fb is the loss in weight, and W is the weight of the body acting vertically downwards. So this is the scenario, and we know that the loss in weight is Fb, and the relative density of the body, is the weight of the body in air, that is W, divided by the loss in weight in water at 4 degrees centigrade, which is Fb. Okay, we also know that the apparent weight of a body in water at 4 degrees centigrade, the apparent weight will be whenever a body is immersed in a liquid, it loses some weight. And the apparent weight, that is W dash, we know is W, that is the weight of the body minus the buoyant force or the upthrust. Okay, these two information we know. Now in in this problem, the weight of the body in gram force has been asked. That is, we have to find W. What is given? The apparent weight is given. W dash is given. Also, the relative density is given. So for this problem, if we apply this formula, we get x, which is relative density of the given in the problem, relative density of the body, x is equal to, let's say, W be the weight of the body in air, W, divided by Fb. Fb from this equation we know will be W minus W dash. Okay, now this becomes equal to W minus W dash. Apparent weight in the problem is given to be y. So we get relation. So we get the equation. So the equation we get is x is equal to w minus w w divided by w minus y. So this is a linear equation in w, and we can easily find w. So this implies if I do cross multiplication, I have x multiplied by w minus y is equal to w. This implies x w. If I bring all the w terms to the left hand side, I have x w minus w is equal to y. This implies w multiplied by x minus y is equals to y. This implies w is equal to y by y by x minus 1. Y by x minus 1. I think I have done some mistake in giving the choices. The choice C, it is xy divided by x minus 1. It should be y by x minus 1. Let me see. Let me check if I did any kind of mistake or not. A solid body have a relative density. So we know relative density is equal to find the relative density of a body based on when it is immersed in water at 4 degrees centigrade. RD, the relative density of the solid, will be equal to the weight of the body in air divided by the buoyant force, which is correct. And buoyant force is equal to W minus W dash. So we have RD is equal to W by W minus W by W minus W dash, which is fine. So x is equal to W by W minus y. Okay. Now x. So if I do cross multiplication, we get x multiplied by W minus y is equal to W. Now, if I if I simplify the left hand side, it is xw minus xy. So there will be x over here. Okay, it is fine. X. So xy divided by x minus 1 will be the weight of the body in ground force. So the correct choice is C. C is the correct choice. Let's see the next problem. A body denser than water at 4 degrees centigrade, weighing P kilogram force kgf in air, loses a weight of Q gram force when immersed in water at 4 degrees centigrade. Let's quickly draw the scenario once again. This is water. We have the solid. Since the solid is denser than water at 4 degrees centigrade, it will sink completely. And this is the weight. It is given the body weighing P kgf, which means that the weight is P kgf. So we can, which basically is nothing but the mass of the body is P kilogram. So this is weight is P kgf. Now if I want to convert this kgf to gf, kgf is nothing but the gravitational force acting on a body of 1 kilogram, and 1 kgf is equal to 10 to the power 3 gf, because 1 kilogram is equal to 10 to the power 3 gram. So P kgf is equal to P multiplied by 10 to the power 3 this much gf. Okay, and we have the buoyant force acting vertically upwards, which is also the losing weight of the body in water at 4 degrees centigrade. So in the problem it is given if B is equal to Q gf. Okay, then relative density of the body is we know as per the formula, the relative density of the body which is denser than water at 4 degrees centigrade is the weight of the body divided by the buoyant force. So weight is P multiplied by 10 to the power 3 this much GF, and FB, the buoyant force, the thrust, is the loss in weight, which is given to be PGF. So unit gets cancelled out, GF, which is the unit, gets cancels out, and this is nothing but 1000 P by Q. This is the relative density. So the correct choice is B. B is the correct choice. Let's see the next problem. Consider Consider the figure below, where a solid body denser than water at 4 degrees centigrade is immersed in the latter with all forces being in gram force. Okay, so in the figure we have the weight acting vertically downwards, the buoyant force FB is acting vertically upwards, and W is in gram force and FB is also in gram force. Then the volume of the body is, then what will be the volume of the body? We know that since the body is completely immersed, the buoyant force or the upthrust is equal to the weight of the displaced liquid, which is water at 4 degrees centigrade, which has a volume equal to the volume of the body. Now, okay, so if we consider the volume of the body to be VML, we must have what will be the mass of the displaced liquid. The volume of the displaced liquid is the volume of the body, which is V, multiplied by the density of the water at 4 degrees centigrade. If we denote it by PW, this much gram is the this V rho W gram is the mass of the displaced liquid, and so the FB, the buoyant force or the upthrust, will be this much gram force. Now we know rho W, the density of water at 4 degrees centigrade is nothing but 1 gram per centimeter cube. So this is equal to V gram force. V gram force. So the volume clearly, so this implies that V is nothing but equal to FB. V is nothing but equal to FB. Because the density of the water at 4 degrees centigrade is 1 gram per centimeter cube, rho W will be 1. So FB is equal to VGF, and FB is the force, the buoyant force. FB is also in, basically, actually we must write to be more accurate. This is FB GF is equal to VGF. Now you can ignore the unit from both the sides, that is GF, and we get FP is equal to V. So the correct answer choice is C. Let's see the next problem. A solid body apparently weighs m gram force and n gram force in a liquid and water at 4 degrees centigrade respectively. Okay, the body weighing P gram force in air is denser than both the water at 4 degrees centigrade and liquid. Okay, if the relative density of the liquid is X, then the value of P is, okay, so we know how to find the relative density of a liquid using a solid body whose weight is W, and from the fact that it's from the fact of its apparent weight in both the liquid and water at 4 degrees centigrade. We know that the relative density of a liquid, relative density of a liquid, relative density of a liquid, let's say L, is equal to the weight of a body, in air. This W is the weight of a body, any body whose density is more than the density of liquid, and the density of water at 4 degrees centigrade. If that body has a weight of W in air, that minus the same body, its apparent weight in the liquid, let that be WL dash divided by the weight of the body in air minus the apparent weight of the body in water at 4 degrees centigrade. Let this be W WW dash. So WL dash is the apparent weight of the body in liquid, and WW dash is the apparent weight of the body in water at 4 degrees centigrade. This will give the so W minus WL dash divided by W minus WW dash will give the relative density of the liquid. This is the formula that we discussed in part 20 video. Now it is given that the relative density of the liquid is X. So we have X is equal to, and also it is saying that the body weighing PGF. So W is P minus the apparent weight of the body in the liquid is M. P minus M divided by P minus N. The apparent weight of the body in water at 4 degrees centigrade is P minus N. So we get this equation. Clearly, we get this is the linear equation in P, and we can easily solve for P. If I do cross multiplication, I get X multiplied by P minus N is equal to P minus M. This implies XP minus XN is equal to P minus M. If I bring P or the term P to the left hand side, I get XP minus P is equal to XN minus M. This implies P multiplied by X minus 1 is equal to XN minus M, and from here we can easily get P to be equal to XN minus M divided by X minus 1. So the weight of the body, this much gram force is the weight of the body. So the correct choice is again I did a mistake in I do a lot of mistake in doing in providing the choices. I'm really sorry for that. The correct choice should have been D. As you can see, both the choices C and D are same. Actually, the choice D should have been X minus 1. So the correct choice is D, but I by mistake I wrote 1 minus X instead of X minus 1. Okay, let's see the next problem. A body denser than water at 4 degrees centigrade weighing small p gram force. Small p gram force loses a weight of Q gram force when immersed in water at 4 degrees centigrade. So when a body denser than water at 4 degrees centigrade is immersed in water, it will completely sink. This is water at 4 degrees centigrade. The weight of the body, it is given, the weight of the body is given to be small p gram force. It loses a weight of QGF. Now, the loss in weight is nothing but the buoyant force, which acts vertically upwards, which is denoted by FB. So the buoyant force is given to be QGF, Q gram force. Okay, how much X centimeter cube of the body will weigh in gram force? It is asking basically what will be the weight of X centimeter cube of the body. Now we can easily find, if you know the density of the body in the CGS, that is gram per centimeter cube, we can find the mass of the body, and from the mass of the body we can easily get its weight in gram force. We need to find the mass of X centimeter cube of the body. For that we need to find the density. We know the formula to find the relative density of a body when it is immersed in water at 4 degrees centigrade. The relative density of the body in this case will be its weight in air divided by the buoyant force, which is equal to the weight of the body is given as P, and the buoyant force, which is the weight loss in weight of the body in water at 4 degrees centigrade, is given to be Q. This is the relative density P by Q. Now this implies that the density of the body is nothing but P by Q, this much gram per centimeter cube. If you know the density, if you know the relative density, then you know the density in gram per centimeter cube. If P by Q is the relative density, then the density is P by Q gram per centimeter cube. So we know the density. So we can say mass of x centimeter cube of body will be equal to the volume, that is x centimeter cube multiplied by the density, which is equal to xp by q, this much gram. This implies weight of x centimeter cube of body will be nothing but xp by q, this much gram force. Hence the correct choice is B. B is the correct choice. So this was a very standard straightforward questions based on the formula of finding the relative density of a body and relative density of a liquid using the fact of apparent weight of a body in the liquid and in water at 4 degrees centigrade. For more details, you can watch video part 19 and 20. I hope this video will be beneficial in giving you a clarity of how to apply the concept discussed in part 19 and 20 to solve this kind of problem. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will end the video here. Thanks for watching, and until the next video, take care and bye.